Hi, welcome back. One of my students sent me an interesting question, and he was asking, well, what are the numbers that have the highest amount of factors, considering numbers below 100? That was the question. And it was a very interesting question. I had never thought about it. But before we go into this part in here, we're going to do it very fast. It's not going to take too much time. I have to explain something. Well, when you factorize a number, for instance, let's factorize number, I don't know, something simple, 24. Factorize. So divide by 2, 12 by 2, 6 by 2, 3 by 3, 1. So 24 is what? Is 2 to the third. Let's write in here. So 24 equals prime factorization, right? 2 to the third times 3. Well, if I get to know all the divisors of 24, so the divisors of 24 are going to be, well, it's going to be 1, right? Oh, let's do it. Come on. Let's have the whole package here. Why not? So, come on, how can you find the divisors? Right? We first performed the prime factorization. Wonderful. Now you put 1 here. 2 times 1, 2. Good. Now, again, 2 times 1, 2. There. 2 times 2, 4. Good. Now, again, 2 times 1, 2 already. 2 times 2, 4. 2 times 4, 8. Okay, another one. 3. 3 times 1, 3. We don't have 3 yet. We'll always multiply this by all of those. And if you bring something new, you write it down. So those are going to be the divisors, you see. So 3 times 1, 3. 3 times 2, 6. 3 times 4 is going to be 12. 3 times 8, 24. Okay, so those are the divisors. So 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 divisors for 24. Now, is there a faster way to at least to count this number? 8. Yes, there is. So, if I can express 24 with its prime numbers, so prime factorization is going to be 2 to the third times 3. Now, how many factors? It's very simple. You take the index and you add 1 and you multiply everybody. So 3 plus 1 times next 1 plus 1. You gotta have prime factorization. Then you add 1 to each index and you multiply. You see? So 4 times 2, 8. No wonder. So this is the amount of factors that we have for this number. So we just wanted to bring the whole idea before. And now let's go to the table. Because in case you don't know that, now we do. Now it's going to be much easier to understand what's coming next. Now, I created this table here. So let's see. I want to start with 2, right? Power 2. Why? Because this the smallest base. So this is going to be the base, and if I write like 2 to the third, I have 8, you see? 2 to the third. And if I have like 2 to the first times 3, you see? 6 times 5, see 30, you see? It's going to be 2 to the first power times 3 to the first power times 5 to the first power, and this is the product. And how many factors? Why 8? Well, because remember the powers? You take the powers in here. Remember the powers? You take the powers, add 1 and multiply. So we're going to have exactly this in here. 1 plus 1, 2, times 2, times 2, 8. Okay, but just to explain. Now, let's start working. Okay, I'm going to go to the 5th. I can still increase to the 6th. Enough. So, if I'm only working with powers of 2, I cannot do anything more than this. 7 factors. Okay, now I would like to put the base 3 on this prime factorization. For such, I already have 3, right? So, so 2 to the 5th? Okay, cannot go any further, agree? I cannot, if I put 2 to the 6th, I go above 100. So, 2 to the 5th. And 12 factors. Interesting. Let's keep that one. Now, I would like to increase the powers of 3. Now, let's try 3 square roots. Okay, I already have 9, right? Okay, now, how can I work with powers of 2? So, maybe 2 to the 4th? Nah, too much. 2 to the 3rd. Okay, works. 12 factors also. Good. You see, I'm not looking here. I'm just taking attention if this number is above 100 and controlling the indexes in here. But this one is also interesting. Okay, now let's go back to 3. Can I increase the power of 3? Very unlikely, because now I have 27. You see, 3 to the 3rd, 27. So should I multiply what by 4? So 2 to the 2nd, even pass it. So you see, I cannot put anything higher than 2. So 8 factors. Nah, let it go. So 3 to the 3rd is not possible. So I cannot increase any more the powers of 3. Now I'm going to leave the 3, but I would like to bring the 5 as well. Let's bring the 5 as well. Good. Now, how can I work with powers of 2? Well, let's see. 2 to the 3rd, too much. 2 to the 2nd, interesting. Of course, we have our old buddy 60, and 6, of course, had to be on this list. Of course, 12 factors. Because when you try to, every time and then when we try to factorize 60, my gosh, it's like what? 1, 2, 3, 4, 5, 6. It seems to never end. So it's funny when you do prime factorization of 60. And of course, it's here. Okay, now can I increase the power of 5? Of course not. So with those, I cannot go any further. Agree? I cannot. If I even increase in here with a 5, look, I have to put what? Only 1, 2. But yes, it works. You see? Interesting. So we have this one as well, you see? So I just kept the 5 and I increase it the power of 3 and kept this one. Can I do the reverse? I'm going to keep the 5, but now I'm going to increase, I'm going to let the 3 and increase the power of 2. Well, this is what I have here. So, okay. What else? I cannot increase anymore. You see, I'm almost touching the 100, so I cannot increase neither here, neither there. So with 5, I can do anything else. Now, let's try to bring the 7 into the play. Let's see. 7 and a 5. Okay. A 3 is not possible. A 2, I don't think it's going to do anything, you see. Power 1, nah, you see. 8 factors, not interesting. Okay, so with 5 doesn't work. So maybe 7 and 3. I don't know. Let's see. 7 and 3, you see? I had to give up of the 5 because I want to bring the 7 into the play. But with the 5 is too much. So I'm going to keep the 3. Now I'm going to increase the powers of 2. So 2 to the 3rd, 2 to the 2nd. Okay, interesting. You see, I cannot go any further. So also 12 factors. Let's keep it. Okay. Now, there is anything I can do now. I would like to bring the base 11, right? This prime into our prime factorization. Well, I cannot put anything here, anything there. Maybe 3 square roots. Yeah, but 6 factors, not interesting. And what happens if I do it here? Okay, 8. Nah. So you see, the most I can put is 3, but it's 2 is not the maximum. It's not interesting to me. I have better numbers with more factors. Well, that's the end of the story, because I cannot go to 13 to put all the prime factors there, because with 11 I can't do anything. You see, if I try in here, we tried, right, to do the third, so it's not enough. So with 11 doesn't work, so I have to stop. So I have 5 options here. So I have the number 60, 72, 84, 90, and 96. So those are going to be the 5 numbers which are the ones that have the most amount of factors below 100. Well, I hope you have enjoyed. That is what I wanted to show you. Thank you very much. See you later. Bye bye.